This is section 3.3, and the title of this section is Summaries for Skewed Distributions. So in the last couple of sections, we've been focused on what kind of measurements we would use to analyze a distribution if it's symmetric. Now we're going to look at what to do if the distribution is skewed. So when it was symmetric, we said the mean was what we wanted to use for the measure of center or the typical value. However, when it's a skewed distribution, now we're going to focus on the median. So what is the median? Well, the median is essentially the number that's in the middle. When the distribution of a data set is not symmetric, the mean, that's the blank that goes here, the mean is no longer the appropriate measure for the center of the data set. Instead, the median, and I'm sorry this is such a small space, the median of a data set is the middle number. You've probably heard that term before. We've probably used it a little bit here and there, but it's the middle number. Let me write that a little neater here. Try that again. The middle number when the data has been sorted from the smallest to the largest. So if we take all the numbers in a set and we go from smallest to largest, the one that's right in the middle is what we would consider the median. The median is the best measure for the center when the distribution is skewed. Oops. Skewed or asymmetric. So let's look at a quick example here. The histogram below shows the distribution of daily high temperatures of New York City from May to September of 1973. About half of the days were above 79 degrees, so about half were above 79 degrees, and about half of the days were below 79 degrees. So what we call the value of 79 degrees. Well, if half the data is above it and half the data is below it, that makes 79 degrees our median. Suppose we knew that the mean was 77.88 degrees. Label both the mean and the median in this image. So the median was 79. I would kind of guess it's about, let's see, we can get it labeled, maybe right about there. We'll put our median, I'm just going to label it like this. That's going to be our median right there. And then our mean is slightly lower, right? I'm totally guesstimating that's probably closer to 75, but we'll say that's our mean. I'm going to use the symbol X bar to represent our mean. So which measure do you think is a better typical value for this distribution? So this distribution, I would say we could argue is left skewed. It looks like it kind of has a tail here and then it bumps up and then has a quick drop off. So since the distribution is left skewed, which measurement would be a better representation for a typical value? That would be the median. Okay, let's take a look at the next example. So these are the summary statistics from StatCrunch for the gas stations. If you remember in a previous lesson, we had a sample of prices per gallon of gas for 48 gas stations. So N is 48. That represents our sample size. The mean is about $2.75. Variance is the square of the standard deviation. We're not going to do much with that right now. Standard deviation is about 0.064, about 6 cents. The median is $2.78. And then the rest of these numbers we haven't discussed yet, so I'm going to hold off on talking about those. But it says find and interpret the median. So the median, and there's no symbol for median like there is for mean, so we're just going to write out the word. The median is about $2.78. So that means about, let's say, half of the stations, the gas, and I'm abbreviating here because I'm short on room, half of the station's price is below $2.78 and half is above that $2.78 price. And if you don't know what the distribution looks like I don't have the data in front of me, so I don't know if this is skewed or symmetric, the median is always a safe measurement to use for that typical value. So that's something to keep in mind as we go forward. How do we measure the spread for a skewed distribution? So the standard deviation, remember what that was when we talked about symmetric. The standard deviation measured it gave us kind of a typical value for the horizontal spread using the distance that was away from the mean. And that's what we worked with when we talked about symmetric distributions. However, for a skewed distribution, since we don't use the mean, we're not going to use the standard deviation. So let's talk about what we're going to use instead. First of all, let me give you some more vocabulary here. The range, we've actually used the range before. I know we talked about it a little bit in chapter 2, but the range, let me write this here for number 1, the range is the difference between the largest and the smallest data values in the set. So if we take the largest value, subtract the smallest value, that gives us our range for our data. The second bullet here, number 2, should be quartiles. So quartiles are the values that divide the data into quarters. So if we take all the data and divide it into fourths, basically, each quartile will contain 25% of the data. The first quartile, the symbol we use is Q1, and if you're talking about a quartile, the first quartile, it has 25% of the data below it and 75% of the data above it. If you kind of think of it in terms of like a number line, if I put, if I have Q1, then 25% of the data would be below it, and 75% of the data, 75% of the data would be the rest of it, that would be above it. The second quartile, Q2, so what would that contain? So if we divide it into fourths, the next fourth would be labeled Q2. How much of the data, or what percentage of the data would be below it? Well, remember, it splits it into fourths, so that means for Q2, 50% of the data will be below it, and likewise, 50% of the data will be above it. So that's your halfway point. So Q2, we don't usually use that term because if half the data is below it and half the data is above it, what you're really talking about is the median of the data. So instead of Q2, we usually just say the median. So then the third quartile would be up here. So the third quartile, if you're thinking about it in terms of your number line, would be up here. So for your third quartile, 75% of the data will be below it, and 25% of the data will be above it. So if I'm at Q3, 75% is down here, and 25% is up here. The interquartile range, or IQR, is defined to be the range of the middle 50% of the data. So the way we can find the IQR, so let me show you kind of here on the number line. So the IQR is the range for the middle 50%. So the middle 50% is right here. So the range would be the difference between the highest and the lowest. So how would we get the IQR? We're going to do Q3 minus Q1, and that's how we're going to calculate the IQR. So when we're working with a skewed distribution, the IQR is what we're going to use to measure the horizontal spread. So let's take a look at an example. A room of 10 people has the following ages. So we've got a sample here, and they're asking us for the range of the data. So we're going to go ahead and just do this one by hand, but a lot of times, especially the larger data sets, we're going to use StatCrunch to figure out the range. And actually, we'll talk about this in the lab, and when you do the homework, you'll see it. But this summary statistics thing that we talked about up here, that gives you the range. You can see that. It also gives you Q1, Q3, the median, the minimum value, and the maximum value. But let's do this one by hand just for some practice. So if we put these numbers in order, well, I'm not going to take time to write them in order, but if we look at it, we can see that the lowest number in the data set would be, looks like it's 18, and the maximum value in the data set would be 44. So the range for this data, and there's not really a symbol for range, I'm just going to write the word out, would be 44, take away 18, which would just give us 26. Okay? The dot plot below shows the distribution of the weights of a class of students. The vertical lines slice the distribution into 4 parts. Each part has about 25% of the observations for the data. So what they're giving you, when they're giving you, this is a sketch, this is different from the ages, now we're looking at some other data set, but they're giving you the cutoffs for the 25% of each 25%. So what does that make this? Well, this first cutoff would be your Q1, your quartile 1. So 25% of the data is below that in this interval. 25% is here, 25% is here, and 25% of the data is here. So let me go ahead and label each of these. So that's Q1. The next one would be Q2, but that we know is really the median. So I'm going to just write median. And then the last one here would be Q3. So they're asking for the IQR for the data. So it looks to me like Q3, if I'm looking at the dot plot correctly, would be down here at 160. And then Q1 looks to me, it's hard to tell exactly, it looks like it might be about 121. So I'm going to say 121. So the IQR, which is going to give us an idea of the spread for this data, is going to be 160 minus 121, which gives us an IQR of 39.